resultant will always be a vector. So vector plus vector gives vector. Vector minus vector also gives vector. Okay. Coming to graphical method, triangle law. First law is triangle law, where we represent the two vectors which are to be added by two sides of a triangle taken in one order. Then their resultant or sum is given by closing side of the triangle taken in reverse order. This was one example. Right. Next, we will go to the second law, which is polygon law. Polygon law of vector addition.
Sir, triangle not fully completed, sir. Numerical value you told.
Completed. We'll get when we do questions.
Numerical, sir.
Oh.
Okay, sir.
That was one. The example was one numerical value.
Yes, sir. That we did not figure out yet.
Polygon law of vector addition. So using triangle law, we can add only two vectors. If there are more than two vectors to be added, 3, 4, 5, some number of vectors. Okay, but before that, before we go for polygon law, you need to know some other things. What are they? See, a vector has both magnitude and direction. Vector quantity has magnitude and direction. Okay. When will the value of a vector change? It will change when either the magnitude changes or the direction changes or both change. Value of a vector changes if you change its magnitude or if you change its direction or if you change both. For example, we have a vector A which is 2i. 2i. 2 is its magnitude, I is its direction. So if I make this 2i 3i, this will be a new vector. It is not vector A. This is some other vector. So its value has changed. What did I change here?
Magnitude.
Change the magnitude. Direction is same, I and I. Okay. Or if I make this vector keeping the magnitude same, if I change the direction, 2j. 2j is completely different vector. So magnitude is same, direction is changed, vector changes. Or this thing, 2i is the original vector. I am changing the magnitude from 2 to 3 and I am changing the direction from I to k. So this 3k is entirely a different vector. That means if either magnitude or direction or both change, then the value of a vector changes. Okay, right. Now, one property of vectors is a vector can be displaced parallel to itself without change in its value. You can displace a vector parallel to itself, and this displacement does not change its value. What does this mean? I have a vector A like this.
Magnitude.
I have a vector way like this. I will displace this vector from here to here. I will not change its magnitude. I will not change its direction. Then does its value change? No. If I displace this vector from here to here without changing its direction, will its magnitude change? No.
No, sir.
If I displace this vector from here to here, its value does not change. But I cannot do this. A is like this. I cannot displace it like this. This is a different direction. It is not vector A. So you cannot do this. You can displace a vector parallel to itself anywhere. Its value does not change. This is one thing. Okay. Next. Another point is that we should know is how to find angle between two vectors. How to find angle between two vectors. Okay, suppose two vectors are given like this. These are the two vectors. This is vector P. This is vector Q. And angle between them is, let us say, some theta. Okay. So if I ask you what is the angle between P and Q, it is simply theta, right? If I give the vectors like this, this is vector P, this is vector Q. Now if I ask you what is the angle between vectors P and Q, this angle theta is the wrong answer. This is not the angle between these two vectors. Then what is the angle? Angle is this. To determine angle between two vectors, first basic requirement is the two vectors should be connected tail to tail. The two vectors should be connected tail to tail. So to do that, I can do that in two ways. I can connect tail to tail. What is tail? If this is arrow, this is the tail, and this is the tip. So to determine angle between two vectors, you must connect them first tail to tail. If they are connected tail to tail here, in the first example, they were connected tail to tail. So there was no problem. But here that the two vectors are not connected tail to tail. Tip of P is touching tail of Q. In this way, you cannot determine the direction or angle between the two vectors. Why? Because, see, P vector, it has direction. It's pointing in some way, it has a sense of direction. And what is that direction? That direction is this. P vector is pointing in this direction. And Q vector is pointing in this direction. So, angle between these two vectors should be this, right? It is not this. It should be this. Then how do you write this angle? To write this angle clearly, what we do is, we will displace any one of the two vectors parallel to itself. So that
Sir,
I will put, yes,
so can't it be tip to tip, sir?
tip to tip. If you connect two vectors tip to tip, let us say this is vector Q, and this is, you displace it like this, tip to tip. Okay, we can connect them tip to tip also.
Okay, sir.
Tip to tip also can be connected, but a more commonly used method is connecting them tail to tail, because it will give you more clarity regarding the direction. So we can do this we can do this in two ways. I will place q as it is. I will place vector q as it is. I will not move vector q. This is vector q. But I will displace vector p. Vector p was initially here. Now I will displace it like this. This is vector p. Now their their tails are in contact. Now angle between them is this, theta. Or you can do it in other ways. Second method is keep p as it is and displace q. I will keep p as it is, vector p as it is. This is vector p. Vector q is here, right? I will displace this vector q parallel to itself so that it comes into contact with this. Now this is vector. Their tips, their tails are in contact. Then this is the angle theta. Suppose we have a, let us say we have a triangle like this. This is an equilateral triangle formed by three vectors. This is O, this is B. So OA, this is one vector. AB is another vector.
Sir, are you writing anything?
Yes.
We can't able to see, sir.
Sir.
Yes, OAB is a triangle formed by three vectors. And this is a equilateral triangle. OAB is an equilateral triangle formed by vectors OA, AB, and BO. Find angles between OA and AB, AB and BO, BO and OA. We want these three angles. Okay, see. Angle, first of all, angle between OA and AB. OA and AB. I will take vector OA, which is like this. I will take vector AB, which is like this. Now can I say that angle, this is OA, this is AB. Now can I say that angle between OA and AB is this angle, which is 60 degree.
Sir,
No.
everything is 60 degrees, no, sir, here in this.
No. Yes, equilateral triangle, all the three angles are 60 degrees.
It's a tip to tail, sir.
So OA, AB are two vectors like this. Can we say that angle between them is 60 degree?
No, sir.
It is wrong because OA and AB are not connected tail to tail. So this will not be the angle between them. What should you do? You should connect them tail to tail. Displace any one of the vectors so that they come in contact with the tails. I will keep B as it is. I will keep vector B as it is. And displace vector A like this. This is OA, this is OB. Now, this is the angle between them. Tail to tail are in contact. This is the angle between them. This angle was 60 degree because equilateral triangle. This angle will be
So 120.
120 degree because this is a straight line. Angle in a straight line, total angle will be 180 degree. This total angle will be 180 degree. This was 60 degree. So 180 minus 60, this is 120 degree. So angle between OA and AB is 120 degree, not 60. Similarly, what about AB and
120
BO?
on this.
So 120.
BO and
120.
OA?
120.
120.
Right. So these are 2 points, 2 important points. You can displace a vector without changing its direction by moving it parallel to itself.
Sir,
Parallel to itself. Yes.
sir, that means without. Can you scroll up once? Yes, sir. That means we can displace a vector without changing its magnitude.
If you don't want to change the value of a vector, but you want to move it, then you should move it parallel to itself.
No, sir. That means if we move it, is there any change in its magnitude or not?
No, how will magnitude change? If I just pick up this arrow and place it here, will its magnitude change?
Okay, sir.
Next, 2 important points. A vector can be displaced parallel to itself and that displacement does not change its value. And to write angle between two vectors, you should always see that they are connected tail to tail. This is the important point. In order to write angle between two vectors, they must be connected tail to tail. Then only you'll get the correct angle between the two vectors. Otherwise, it's wrong. Okay. Next. Suppose I have this vector. I have this vector. If I rotate this vector by 360 degree, will its value change?
No, sir.
No, sir.
No, sir.
If I make a 360 degree rotation of this vector, it will go like this and again come point in the same direction. So its magnitude is not changing and its direction is also not changing. So its value will not change. So 360 degree rotation of a vector does not change its direction. If I rotate it by 40 degrees, 30 degree, 90 degree, 120 degree, 150 degree, any angle other than 360, it will change its value. And if I rotate a vector by 180 degree, this is vector A. If I rotate it by 180 degree, it will become like this. Then what is this vector? This is minus A. Opposite of a vector. So if the direction of a vector is reversed without changing its magnitude, then you get a negative vector. Okay, now come back to polygon law. Polygon law of vector addition. Okay, what does this law say? We take the statement of the law. If n vectors are represented by the sides of a polygon taken in order, then the resultant is given by the closing side of the polygon taken in reverse order. Similar to triangle law, the only difference is there we use only two vectors. Here we use a number of vectors. Polygon. What is a polygon? Polygon is a closed figure with three or more than three sides. If you have three sides, you call it as a triangle. If you have four sides, you call it as a quadrilateral. If you have five sides, you call it as a pentagon. Six sides, hexagon. Seven sides, heptagon. Eight sides, octagon. We have names only up to the 8 sides. So all these are polygons.
Sir, after it.
All these are polygons, whether it has 4 sides or 5 sides or 6 or 7 or 8 or 9 or 10 or 20, whatever number of sides it has. In general, it is a polygon. Poly means many. Okay. So if I have n number of vectors, let us say 3, 4, 5, 6, some number of vectors, and I want to add them graphically, then I will take all those vectors and represent them with sides of a polygon like this. This is vector A. This is vector B. This is vector C. This is vector D. And this is vector E. 5 vectors. I'm taking 5 vectors. And I'm arranging them so that they form an incomplete polygon.
Sir,
Then the resultant of all this, listen completely, then ask your questions. So if I arrange these vectors like this, then the resultant of all these 5 vectors, that means vector A plus vector B plus vector C plus vector D plus vector E is given by the closing side of the polygon, which is this. Let us say this is some R resultant. So vector R is equal to vector A plus vector B plus vector C plus vector D plus vector E. Like this, you can add any number of vectors using a polygon. It can be, if you actually, triangle law is a kind of polygon law itself. Triangle is a kind of polygon law, or polygon law is repeated triangle law. So polygon law is repeated triangle law. How? See, take the two vectors A and B first. Vector A and vector B. I will draw them here. This is vector A and this is vector B. The resultant of these two will be, according to triangle law, it will be this. Let us say it is some P. So here, vector A and vector B, if you add them, you will get this thing. Okay. Then you forget A and B, look at only this P. Now look at vectors P and C. Again, if you apply polygon triangle law to vectors P and C, you will get a vector like this. Let us say this is some Q. Okay, forget vectors A, B, C, and P. Look at vectors Q and D. You can again apply triangle law there. Then you get this resultant. Let us say this is some X vector. Look at X vector and E vector. Again, you can apply triangle law. Resultant will be this thing. So in that sense, polygon law is repeated triangle law. Okay. Polygon law, right? Next, the third law that we have, third graphical method to add vectors, which is the most important one. But I think you might not be able to finish it. Okay, it will take. Yeah, it takes time. We will have to derive a small the expression for the resultant of that parallelogram. Okay, better we take it up in the next class. Right. For now, these are the two things: triangle law and polygon law. And suppose if I give you a question like this.
Sir,
Yes.
sir, in the graphical method of representing vectors, the arrow show the length of arrow shows the magnitude, no sir.
Yes.
Then the length of vector r is equal to all, no sir. How the vector r is equals to a vector plus b vector, like so on, sir.
You are thinking only of magnitude, but you are forgetting the direction. This is 10 Newton force. This is 5 Newton force. If I add these two, what do I get?
15
Newton.
Newton force. Okay, fine. This is same 10 Newton force. This is 5 Newton force. If I add these two,
5 Newton, sir.
5 Newton, sir.
is the magnitude changing?
Yes, sir. Yes, sir.
This is 10 Newton. This is 5 Newton. Will the magnitude of these two will still be 15?
No, sir. It will be somewhere around 5 Newton and 10 Newton.
Right? Oh, okay. If I add one more vector, which is like this, 2 Newton. If I add one more vector, which is like this, 6 Newton. Every time the magnitude changes, right? You need not
Yes,
always
sir.
get 10 plus 5, 15. In the same way, A is pointing in one direction, B is pointing in other direction, C in other direction, D other direction, E other direction. Then if you add these vectors along with their directions, then the magnitude of all those, the sum of all those vectors will be this thing.
Sir, I have a doubt.
Let us take an example. Let us take an example. You start from your home. You go to school. You go to your friend's house. From there, you go to market. From there, you go to park. This is your journey. Now, how far away are you from your home? Let us say from home to school is 1 kilometer. From school to your friend, it is 2 kilometers. From your friend's home to market, it is 2 kilometers. From market to park, it is 1 kilometer. Then, if I ask you how far away are you from your home, will you
6
say
kilometers.
plus 2 kilometer plus 2 kilometer plus 1 kilometer? Or will you say this
This sir.
this thing?
That. Yes, sir.
It can be half kilometer, it can be 4 kilometer, it can be 100 meter, any value depending on your path followed,
Sir,
starting and your final positions. Yes.
once can you scroll up? I have a doubt. In the diagram, sir, you only give one resultant, no, sir.
Hmm.
Can a polygon have one or more resultants?
Suppose if I add 4 numbers, you get only one number, right?
Yes, sir.
You are following here. This is one path. This is your second path. Third path. This is your fourth. Someone has to mute their audio.
अच्छा मैं 10:30 से फोन करता हूँ.
Taufik, mute your audio. So you are following 4 different paths of different magnitudes and different directions. Ultimately, how far away are you from your home? This is the distance, displacement.
Sir, I have a doubt.
Hmm.
Sir, if there are, according to triangle law or polygon law, if there are two vectors in 90 degrees, then the third reverse resultant we can obtain by using Pythagoras theorem, no, sir.
Only when the Pythagoras theorem, you can say it is an instance of triangle law.
Yes,
For
sir.
one particular situation of triangle law, you can apply Pythagoras theorem, not always.
Sir, then what about when it is not 90 degrees, sir? How can we get the value?
There you should use geometry. Triangle law and polygon law, there are more of qualitative type. Triangle law and polygon law are more of qualitative type. They give you the idea of that magnitude and direction. If you want numerical value, what is the magnitude and what is the exact direction, you should go for the third law, which we have parallelogram law.
After understanding parallelogram law only, we'll understand numerical, sir.
Yes, we use parallelogram law in 95% of the cases to find
Okay,
resultant
sir.
of two vectors.
Sir,
Yes.
sir, you show that vector R equals to vector A plus B plus C plus D plus E, right?
Yes.
So why are we not adding vector R also?
R is a resultant, no?
Okay,
1
sir.
plus 2 plus 3 plus 4 is 9. 9 or 10.
Okay, sir.
10. So 10 is that R. Okay, so different methods to add vectors. One most important method that we will be using after we learn that thing is parallelogram law of vector addition. Most important thing. practically when you study these vectors in physics, particularly in motion, we use vectors in almost all chapters of physics except a few, like heat and modern physics, except a few chapters. In almost all chapters we will be using vectors. If you study or when you understand the application of these vectors to those physical situations, you will understand, you will get more clarity on these things. Okay, right. So that's all. We'll stop here and discuss parallelogram law of vector addition in our next class.
Bye, sir. Good night.
Bye, sir. Thank you. Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir. Good night, sir.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.